In this video, we'll see how to use a header node in a linked list. A header node is a special node that is present in the beginning of the list. The link part of this node points to the first real node of the list. These are the real nodes of the list and this is the header node. Info part of this node can be empty or we can use it to store some useful information about the list like the number of nodes in the list. This head pointer always points to this header node. So head link gives us the address of the first node of the list. This header node is never deleted. It exists even if the list is empty. For an empty list, the link part of this header node is null. Now, use of header node simplifies certain operations because by using a header node, we ensure that each node has a previous node and there is a node even if the list is empty. By using this header node in our list, we can reduce some special cases in our code. For example, in the functions delete node and insert before that we had written in our single linked list program, we can remove first two special cases if we use a header node. We'll see this in our program. This is the program for a single linked list with a header node. Here we are allocating memory for a header node and we are making this head pointer point to this node. The info part of header node is 0 and the link part of this header node is null, indicating that the list is initially empty. Now this head pointer always points to this header node. So in all these functions, we don't need to return the value of head. So all these functions are void. Now let's see the functions one by one. This is a display list function. If head link is equal to null, it means the list is empty and we'll just return. Otherwise, we'll initialize p with the address of the first node. The address of first node is in head link. And then we'll traverse the whole list and display the info values. Now let's see this insert at end function. Here we are allocating a new node. Here we are finding a pointer to the last node of the list. And here we are inserting the new node after the last node. Now this function insert at end can be used to insert a new node in an empty list also. In the case of an empty list, head link is null. So this loop will not work at all. And the control will come here. T will be equal to head. So head link will be equal to temp and temp link will be equal to null. So we can use this loop for insertion in an empty list also. Now let's see this create list function. In this we have used this insert at end function to insert all the nodes of the list, including the first node, because we have seen that we can use this function to insert in an empty list also. Now let's see this insert before function. Suppose we have to insert a new node before the node that contains value x. So we find pointer to predecessor of node containing x and then insert the new node. This is same as we had done in the single linked list. But here we have removed the first two special cases, which we had to write in the case of a single linked list without a header node. Let's see the insert before function of a single linked list without a header node. So here we have these two special cases, if the list is empty and if the new node is to be inserted before first node. And after that only we find pointer to predecessor of node containing x. So these two cases have been removed in a function insert before that we have written for a single linked list with a header node. Now let's see this insert at position function. In this case, we have to insert a new node at the kth position in the list. Let's see this function for our linked list without a header node. So here we have to check for this special case, which is not present in a single linked list with a header node. Now let's go to a delete node function. Here also, we don't have to put the two special cases that we have to put in a single linked list without a header node. Let's see the delete node function of a single linked list without a header node. So here we have to put these cases if list is empty and we have to delete first node. These two special cases are not there in a single linked list with a header node. We are directly deleting the node in between the list or at the end of the list. Now let's run this program. This is our list First we insert a new node at the end of the list. This is inserted at the end. Now we insert a new node before our given node. So this 33 is inserted before 3. Now we insert at a given position. This 66 is inserted at third position. Now we delete a node